Let's focus on the Cron facility, the scheduling facility, now that we've looked at YUM as well as RPM. So Cron features a scheduler, and a scheduler within an OS environment provides the ability to execute commands at a desired schedule. Now Cron follows some rules. When you create an entry, the rules are based on times, and the times are governed by the various columns that are or that precede the command that is to execute. And they include the minute, which can be 0 through 59, meaning the process can execute either at the top of the hour or before the top of the next hour, or any minute between the two. So between the top and the minute before the top of the subsequent hour. The second column in the rule that you create, or the cron entry, so rules will also reference as cron entry or cron entries, pertains to the hour of the day that the process is to execute, which can be one of 0 through 23 and can be multiple options. So if you'd like a process to run, let's say for example at midnight, then 2 a.m. and then 6 a.m., you could indicate 0, 2, 6, and Cron would run the process on those hours. The hour column is followed immediately by the day of the month, or DOM, which is one of 1 through 31, depending on the month, of course. And again, just like the other fields, can be combined to represent multiple days of the month, such as the 1st, the 15th, the 19th, and the 24th. After the day of the month is the month. This influences the months in which the process, months in which the process will execute, 1 through 12. So if you'd like a process to execute all months, you could indicate asterisk or specific months such as January and February, 1, 2, or 1 through 2. And the fifth column is a day of the week, or DOW, which you can generally indicate as the 3-letter prefix such as Sunday, Monday, Tuesday, etc., or 0 through 7, with 0 and 7 representing Sunday, which means 1 through 6 represents Monday through Saturday. So again, Cron is a scheduler, and it accepts rules in various files that it processes, and the rules should contain the time that the process should execute, and the final column, the fifth or the sixth column, contains the command to execute, which can be a shell script, Perl script, etc. Now let's take a look from the shell at how Cron is implemented. An RPM query Cron reveals that it's not installed. Query all grep I Cron reveals that it's indeed installed, but instead of as Cron, it's called Vixie-Cron. RPM query list Vixie Cron is actually split out into multiple packages, Vixie Cron and Cron tabs, but Vixie-Cron reveals the included items, including etc cron.d, which is a container for cron entries, a PAM entry for authentication, an initialization entry so that the process can be started whenever the system starts or whenever the system enters a run level that Cron should execute in, a sysconfig entry, which influences startup as well, Cron tab, which is the program which allows you to maintain a user's cron tab. The main daemon itself, cron d, and in fact if you psef grep Cron D, you'll see that it's running. It's always running, by the way. And documentation, as well as varspool cron, where you'll find individual user cron items. So in addition to being a scheduler and accepting rules, cron wakes up every minute in search of programs to execute, and it checks the various schedules that it is responsible for, and if it finds a process or more that need to be executed at the current minute when it wakes up, it will execute the process or processes. So it wakes up every single minute and it searches various places. Now what are those places? We see etc cron.d as well as varspool cron. Well, in etc on a Red Hat system, you've got multiple cron entries. Let's just copy and paste these items and discuss them briefly in our text file. So it reads cron entries or cron tabs from multiple files. And they're primarily located beneath etc, and they resemble, or they are these files. Items beneath cron.d will be included. So for example, let's just take a brief look at cron.d. It's empty. But if you insert a file, an entry with a schedule, it'll be executed according to schedule. Cron.deny. That's less etc cron.deny. Let's see if it even exists, and it does. Any user placed in this file will be denied access to execute cron. So let's just note denies cron execution by user. Cron.monthly runs jobs monthly. And let's just take a brief look at the cron.monthly directory to see what's there. And we see an entry for anacron, which is a process that covers for cron in the event that cron is unable to run processes on your computer because it's been powered off for some amount of time. So it runs jobs monthly. Whereas cron.weekly runs jobs weekly. Let's take a brief look at a default Red Hat installation to see what's in here. Here we see anacron once again, as well as make what is, which is another job. And if we examine the contents of cron.weekly, make what is, for example, you'll see that this entry is a bash shell script with a description of what it does. And if we examine anacron, or zero anacron, and zero is to ensure that it runs first, it too is a script, a bash shell script, which will run items that were not executed. Cron.daily is similar. Items that are to be executed daily will run if they are in the daily directory. And a brief look at the default location will indicate what runs daily on the system. Entries for cups, log rotate. Perhaps log rotate is the most important process. That's less cron.daily log rotate, which we have yet to look at. And on a daily basis, when cron executes the daily jobs, one of them will be the log rotate package, which processes a configuration file from etc, and it makes sure that it logs the item if the exit status is not 0. In other words, if a failure to rotate the file occurs, or files occur, then the logger is called and an appropriate entry will be logged related to log rotate that you can find in the messages file. Cron.hourly runs jobs hourly. Let's see if there are any entries. And there are none. And then there's a main cron tab file. This file contains general schedules, general system schedules. So contains system-wide schedules. It is also a place where you may place cron entries for, let's say, tasks that you'd like to run that you'd normally assign to root. just to keep it in a centralized place. We look at cron tab and we see it includes a few defaults for shell, path, mail to, and home. So whenever these items run, they will include or run the bash shell with the following path. Messages, success or failure messages will be sent to root, and the home directory is the root of the file system. After that, we see entries for hourly, daily, weekly, and monthly, the items that we just completed talking about. Each item includes the columns we've mentioned: minute, hour, day of the month, month, day of the week. So for example, cron hourly items will run 1 minute after every hour, every day of the month, every month, every day of the week. An asterisk means execute for every instance. So note, asterisk or wildcard in a column means, or in a time column, means to run for all values. So in the case of the first entry, there are asterisks in 4 of the 5 columns indicating that for all of those times, providing it meets 1 minute after all those times, then the process will run. So every day of the week, Sunday through Saturday, every month, 1 through 12, every day of the month, 1 through 31, every hour, 0 through 23, providing it's 1 minute after the hour, execute cron.hourly processes. Cron.daily entries are executed 4 hours and 2 minutes for every other item, such as day of the month, month, day of the week. Cron.weekly entries are executed on Sundays at 4 a.m. and 22 minutes. Cron.monthly entries are executed, as you can see, we've got minute, hour, day of the month. The first day of the month, 4 hours and 42 minutes. Now we can append to the cron tab file our own entries, or we can do so to individual users. So we should note as a 5th feature that cron maintains per user and system-wide schedules. We've just looked at the system-wide schedule, which is located in etc cron tab, which references the daily, hourly, weekly, and monthly items. Per user, however, items are stored in the var spool directory, the var spool cron tabs directory. So per user cron tabs are stored in var spool cron tabs. Let's take a brief look to see if there are any entries defined. And there we see cron is empty, so that's var spool cron is empty. So with that said, our first task is to create a cron tab entry, or cron entry, for the user student1. A simple job will suffice, and we'll do so where student1 exists. Let's grep student1 from etc password to be sure this user exists, and the user does. So first and foremost, we'll su in as the user. Once in a student1, we'll execute crontab-e to edit our crontab entry, which will be blank initially. So crontab-e. This will launch the default editor, which generally is VI. Now we're in VI. If you're not familiar with VI or would like a different editor, export the editor variable, setting it to something like nano. And then we'll re-execute crontab-e, and it brings up the schedule in nano. Now once in nano, you indicate the key columns minus the username column, because this crontab entry will ultimately be saved as a crontab entry for the user student1. So step C, create an entry minus the name of the user. So that means all of the columns that define time, as well as the command. But we need a command to run in order for this to work. So in a separate shell, let's go ahead and su in as student1. We'll su as root first, and then su in as student1, and then create a script as student1. So we need something to do. Well, let's run uptime and see what's of interest. When we run uptime, and this is a script that we like to write because it's easy, works well, we see that it produces useful information. How about if we wanted the load average information? Well, this gives us a good opportunity to take advantage of awk in a shell script. So uptime piping the output to awk, parsing out some key columns. Since these columns are delimited by space, we'll count out as 1, 2, 3, 4, 5th, 6th, 7th. Let's say we want 8th, 9th, 10th, 11th, and 12th columns. So we'll awk print 8, 9, 10, and column 11. Let's see how this works out. So the load averages return, we're missing one item apparently. Let's go ahead and get column 12 as well. Now we have all of the load averages. Now supposing we wanted to store this information for further processing at a later time, but we want the system to do it using cron. Take this series of commands, which includes uptime and awk, and create a script. We'll do so in the shell environment since we're logged in on the desktop as Linux CBT. So we'll nano, and we'll reference using a shebang header bin dash, and then paste as our first item the following. But we want to send this to a file using append redirection. So we'll append, and we can define a file name if we'd like. Let's call the file name load average. Or load averages plural, and then send our output using append redirection into file name. And before we commit this shell script to cron, we'll be sure to test it. So let's save it. We'll call it load averages. .shell, and then we need to flag it as executable. So we'll change mod +x load averages, then LSL to be sure that it's executable. Now let's try to run it. ./load averages will echo the exit status, and it seems to have run successfully, creating the load averages file. We'll less it, and there we see the load average. It's always a good idea whenever creating cron scripts, however, to reference the full path. So let's modify it once more and indicate that the file name will be home student1, and let's be sure that student1's home directory is indeed in home. So we'll exit this entry, and it's actually home1. We made a change, so it's going to be home1 student1 load averages.text. Let's try to execute it again to be sure that it works. Always test your scripts before committing them to cron for obvious reasons. And we missed student1 in the name of the file name, so let's modify load averages.shell script again, and that's student1, save the changes, and then try it again. And we're obviously missing it. Let's see where we are. And it's home student1, so we definitely, but this is on the local system, so we've got it mixed up with the remote system. That's why the difference. So let's log out of this shell, SSH over to the remote system, since that's where we're working. That's the reason for the confusion. Then SU in as student1. And now we can create the load averages script. So let's copy it, or start over creating it, either or. Since we have it local, we'll get it from our local instance from a separate window. Then we'll scp load averages.shell. over to 192.168, or we could simply cat it. Let's cat the contents just to save time, as it's a simple script. It's just a 3-liner. Then on the remote system, we'll nano load averages dot shell, paste the items, and then test it by change modding +x load averages dot shell, and then trying to execute it, where we see that it has run successfully, and a cat of load averages dot text looks like what we want. So again, it seems to be working. Let's cat the contents of load averages dot shell to see why it stripped the initial field. Let's uptime, and because the fields are displayed differently, it returned it slightly differently. So in this case, it's specifying the fields as the 1st, 2nd, 3rd, 4th, 5th. So we really need to get 6th, 7th, 8th, 9th, and 10th. So different systems causing the output to be displayed differently. Let's nano again. That's going to be 5 through 9. But before we modify it, let's just dump the output to the screen to be sure that it works. And notice awk simply discarded the fields that were not available. So we'll strip 10 through 12. Again, differences across systems. And that looks more like it, although it got the users, which we didn't want, so perhaps it's fields 6, 7, 8, and 9. That's more like it. So we'll update our script with the new set of fields, and then move on. Again, always test your scripts to be sure that they work before committing them to the process, into the cron environment. And now when we execute load averages.shell and cat the contents of load averages.text, it looks better. That's more like it. So for this user, we'll cron tab E and then place a schedule. And again, you see it's using VI, so let's export editor, setting it equal to nano, and then cron tab E again. So we want it to run every minute of every hour, of every day of the month, of every day of the week, the following command. And on the remote system, let's just be sure we have the full path. It's home1, student1, load averages dot shell. Let's be sure that that's the name of the script, and it is load underscore averages dot shell. That's all we need to do. We'll save this, and now the entry gets written in var spool cron. To confirm it, cron tab as the user list -L, and you'll see the entry and its schedule. So we've created the entry, and just note cron tab -L enumerates per user cron entries. In our case, there's only one entry. So when cron wakes up at the next minute, this process will execute. And we can watch it based on the current time to see whether or not it will run. We'll cat the contents of load averages.text, where it currently has only one load average line, and it will run momentarily. Now when cron wakes up, again, what it's going to do on the remote system, let's just show you, is read, in addition to other things, var spool cron, where it'll find an entry for student1. There's the entry. A file against student1 tells you it's ASCII text, and if you cat its contents, it basically has the entry that we defined, instructing it to execute the load underscore averages.shell script. Now that's per user, but system-wide, would be affected by updating etc cron tab. So it's stored in etc cron tab. Update this file, and you'll be off to running things from the system. So create a cron entry in etc cron tab to do something, such as pinging a remote host and keeping track of it. Again, we have to determine what we want to do, and we could even do it on the local system to avoid confusion. So supposing we wanted to ping our default gateway to make sure it's up, sending 3 packets every minute. will ping-c3 192.168.75.1, and it returns the following output that we'd like to place into a file. So as root, let's define the script in our home directory. We'll nano and call it pingtest.shell, reference the location to the bash shell, and then indicate our command as ping 192.168.75.1, sending the output into file name. And that'll be located in root ping_test.text using append redirection. We'll test it first, and then, after flagging it executable, of course, and let's just take a look. We referenced the wrong variable. It should be file name 1. And let's try that again. And that looks like it's working. Let's cat the pingtest.txt file, and there you have the output that's of interest. So now we can place this into the global file. Let's just copy the name, then nano etc cron tab, and again we'll have the entry run every minute. Big difference in the global file is that you indicate that the user with which cron should execute the process. In this case, the user is root, followed by the full path to the process, which is root pingtest_shell. Again, in user-based cron tabs, because the files are named accordingly for the user, there is no need to specify the username. But in system-wide cron tabs, you need to be explicit about who the process should execute as. Let's save the changes, and every minute the process will run. Cron is, again, not very complicated. Once you understand the scheduling, then it's left up to you to define a script, a runnable script, such as Perl, PHP, Python, or Bash shell, and then program it into the cron scheduler, either on a system-wide or per-user basis. Now let's check on the progress of student 1's shell script. We'll cat the contents of load averages _ text, and there you see multiple entries, telling us that it's running as expected. And if we check for an update on the ping test, we should see that it has written additional items to it. Now you can interrogate a remote system's or remote user's entry if you'd like, and we catted the wrong one, it's pingtest.text. Cron entries using cron tab. Let's just note that cron tab-l followed by username does what we mentioned above, which is to enumerate the specific user's entry. But above is the form that you'd use if you're logged in as the non-privileged user. If you're logged in as root, execute it this way. So if you're root on a system, let's say on Linux CBT Serve 4, and you'd like to see student 1's cron entries, short of actually navigating into var spool cron, cron tab list student 1 will do the trick. And this will tell you student 1's entries in the cron table. And there we see the entry. That's list-u username. So as root, we can enumerate other users' cron tab entries. However, as a non-privileged user, you're unable to list root or other users' cron tab entries. So now cron will wake up again. It's always running. It's a daemon. But it'll wake up every minute in search of changes to any of the cron files. It looks for changes in the modification time of those cron entries. It also searches for new entries in var spool cron to determine whether or not they're to be processed and executed. And if so, again, it launches them, does what it's supposed to, and it will also send a mail to the user indicating, in particular the root user, indicating whether or not the process has executed. Cron also maintains a log file beneath var log, known as cron. You can tail the contents of this file to determine if Cron's doing what we expect it to do. Both Red Hat systems maintain the Cron entries, and all Linux systems support it, but not all Linux systems enable it by default. The key to understanding Cron, just to recap, is its scheduling capabilities. The fact that you can indicate items to run every minute, hour, day of the month, day of the week, and the fact that you can use asterisk and multiple steppings, such as 0, 2, 4 to run things at the 0th minute, 2nd minute, and 4th minute. Using commas as well as dashes like you see here, you can indicate a range or multiple items for the schedule. Apart from that, it's really straightforward. There are entries in there to help you get started with running your processes. But understanding and using Cron begins with having to have something automatically run without your intervention. So once you have a process that works without Cron, outside of the Cron facility, then you may either set it up on a per-user basis if the user has enough privileges, or even per-user free root, or even system-wide in the etc cron tab file. And one other note, you should try and schedule your Cron entries to run when other Cron entries aren't running, so that they don't end up competing for and monopolizing the system's resources.